Hi, I'm an old guy and I do maths. And today we're looking at more simultaneous equations. We're looking at ones where there are non-linear elements. And we have an example here. Y is equal to x squared, y is equal to 6x minus 9. And I've drawn x squared in on my rudimentary Cartesian plane. We'll come back to what this graph looks like once we've done some working. Okay, so what we're going to do is we're going to use substitution. We're simply going to say that, okay, if y equals this and y equals this, then this should equal this, and this is what we're going to put in here, and we're going to assume that we're going to rearrange this and make y equal 0, which is what y equals 0 is doing here in the brackets. So we rearrange this. We move the 6x and the 9 to the left-hand side of the equation by adding 6x and negative 9 to this. And we get x squared minus 6x plus 9 equals 0. And then we just set about solving this. And it turns out that this is a perfect square, which is nice and handy. So we have one solution. And that solution is x equals 3. And if we put x equals 3 into each of these equations, we get the same number, which tells us, first of all, that this is correct, and that our point of intersection is has got a y value of 9. So our point of intersection is 3, 9. Okay, so that allows me to draw this thing roughly. Let us say that this point here is 3, 9. So what we see in this example is that the line 6x minus 9 doesn't go zooming through the quadratic and hit it twice. It just glances it, hits it once. So there's one solution to this problem, okay? And that solution is 3, 9. Now, the obvious next question is, what happens when a line does go through a quadratic like this? And what we've got is we've got the same starting equation, and this is y equals x squared here, and we have a different linear equation, y equals negative 5x plus 6, and I've taken the liberty of roughly drawing a line that looks vaguely like this. Only has to be vague to give you a rough idea. Now, going through the same process as last time, but skipping a step or two, we make this equal to this, and we get x squared plus 5x minus 6 equals 0. So basically what we've done is we've said x squared equals negative 5x plus 6, and then we've made it all equal to 0, getting everything on the side of the equation. When we factorize that, what we get is x plus 6 and x minus 1. That tells us immediately that we're heading for two solutions. And x is either equal to 1, this is null factor law in operation, or x is equal to negative 6, two solutions. Okay, so what are the points of intersection? Well, they are 1, 1, and badly written negative 6, 36. And how did I get those? Well, I got a little bit lazy. I didn't bother putting it into both equations. I put 1 into y equals x squared, and I put -6 into y equals x squared, and I got these 2 points. So 1, 1, this is 1, 1 here, badly drawn, and this is -6, 36. I hasten to add, not drawn to scale. But what we have is a process by which we've discovered 2 points of intersection on the parabola when we overlay the line -5x plus 6 across it. Okay, I hope that is clear. It's just a little more complicated than the first example. Okay, right. Well, there's one more thing to look at, and this is pretty short and sweet. We can deal with this really, really quickly. This is where there are no solutions, where these two things don't intersect. And if you're good at drawing, graphs, just drawing the graphs of these two things will solve your problem for you, even though there's no solution. Okay, so this is y equals -x minus 3. Right, well, let's just go through the motions. Let's just assume that you're not into the artwork. So we make this equal to this, and we come up with this quadratic. This is not easily solved. What are the factors of 3 that add to 1? Well, I defy you to find those quickly. So we're looking to solve this using the quadratic formula or by completing the square. Again, ignoring the fact that this may have been drawn, and we may well know that there's no, these things don't touch, so there's no solution. What's the process? Well, what I would do is I would check and see whether this part of the quadratic formula, now the quadratic formula is -b plus or minus all over 2a. And what I'm looking for is this part of the quadratic formula. I want to know if that is positive, 0, or negative. Now, my strong suspicion is that it's negative, that it's below 0. But let's just go to work. So 1 squared, that's b, minus 4 times a, which is 1. 4 times 1, we're already in the negatives, but just for the sake of completeness, times 3. So that is 1 minus 12, which is -11. We're not looking for, we're not going to go looking for the square root of -11. It's not a real number. So there's a video on my channel about what no solutions means, or what no real solutions means. This problem has no real solutions. These two graphs don't intersect. That's really all that's important in this case, and it is the sort of third possible outcome for when you have two functions and their graphs, and you're wanting to see whether they intersect. It's possible that if one of them is nonlinear, you could have 2 or more points of intersection. You could have 1, or you could have no points of intersection. And this is the case here. Thanks very much for watching. I hope that was useful. See you next time.